Okay, this is derivation 2008. We're trying to show if r or not t, then if s then r. So we'll assume the antecedent r or not t. We'll go ahead and show the consequent if s then r. We'll go ahead and assume cd, and we're gonna go ahead and try to show the consequent again and assume id. So we have r or not t, we have s, and we have not r. The first thing we might notice is that r or not t can combine with r with mtp. That will give us not t. Second thing we might notice is that 4 is the antecedent of the second premise. So we can say for premise 2 modus ponens, and we have if not q then t. Third thing we might notice, well, we can do 7 and 8 modus tollens. And at this point we've used everything in here in terms of elimination and introduction rules. But we haven't used, the one thing we haven't used yet is the first premise. So what's going to happen is we're going to use 6 and we're going to use 9. And 10, 11, and 12 are inconsistent with one another. A couple ways to see that. So the antecedent of 10 is if p then q. So if p then q is true, then 10 tells us that r is also true. But we know that r is false according to line 11, and that means that the antecedent of 10 has to be false. However, line 12 is q, and that's the consequent of if p then q. And we know that if the consequent of a conditional is true, then the whole conditional is true. And we even have a rule that tells us that. We have the rule MC. This is another derived rule. I've talked about a couple times now. You can get it from Theorem 2 and Theorem 18. There are two different forms of it. This is one of them. And so those are Chapter 1 problems. So Chapter 1, 101, and 1, 118. So very useful rule. We can say 10, 13 modus ponens, and then we have 11, 14 indirect derivation, and then this will just zip back up. Right, we'll have r is the consequent of line 3, and 3 is the consequent of line 1. And so that's the completed derivation. Now, if you get to this point here, and you're not sure what to do, you probably did this. You said, oh, I have I have a conditional, and I have the negation of its consequent on line 6. And you get to here. Now here there are a couple of things you might do. One is you would show a negative 11. And if you look, you say, what do I need to box and cancel that? I need q. And you think, well, I have q from line 9. This is basically the same derivation. It's just slightly rearranged. Again, we're getting from q to if p then q. The conditional gets us to r, and that contradicts not r. So you could do it like this, and then you'd say, and again, at that point the derivation zips back up, closed. There's also a rule that we have, a derived rule called NC, which says negation of a conditional. Remember, there's only one way for a conditional to be false, for its antecedent to be true and for its consequent to be false, and that's what this theorem says, or derived rule. I don't remember off the top of my head the theorem that enables this derived rule, but we can look, if we go to rules, scroll down, and let's see, where is NC? Here, NC, so theorem 40, so that's problem 240, will enable this theorem. And at this point, you can break off the not q, and that contradicts 13. Again, these are all just different ways of bringing out the inconsistency between this and this and this. Right, we cite line 6, we cite line 10, and we cite line 9 in the justification. So those are different ways of getting to r, at which point, again, as I say, the derivation zips closed. So that's 2008. Hope that was helpful.